Hi, this is part 2 of our notes for 3.3. I'm sorry, I didn't realize that my time was running out. So I'm going to restart the example for if you didn't remember to factor out the negative. So the first thing that I'm going to do is I'm going to notice that all three of these have a coefficient. So I'm going to rewrite using the power property backwards. So the first term is going to become log base b of x to the fourth. The minus sign is going to stay the same. The second term is going to become log base b of 6 squared. And the last term is going to become minus log base b of y to the 1/2. Okay, I always use an eraser. The 6 squared, I'm going to change to 36. And the y to the 1/2, I am going to rewrite as the square root of y. Okay, just to keep things cleaner. If you can start to go to that in your head, you're fine. Okay, you can go right to those in your head. Right in the first step. Okay, so now I notice that my first two terms are a difference. So that means I can use the quotient property backwards. So log base b of x to the fourth over 36 and the minus log base b of the square root of y stays the same. Okay, so the quotient property tells me that when I condense, I take the log of the same base. The first term is my numerator. The second argument of the second term is my denominator. Okay, and so now again, I have the same base. I have a difference, so I'm going to use the quotient property again. The argument of my first term is my numerator. The argument of my second term is my denominator. Okay, but now we have this complex fraction, and we never like to leave a complex fraction. So we are going to rewrite this as the numerator times the reciprocal of the denominator. Okay, and this is just rules of fractions. And then we are going to multiply to get log base b of x to the fourth over 36 square root of y. Okay, I'm going to go back to my old notes for a second. So if you notice, okay, down here, we got the same answer as up here, except for the parentheses, which I actually like it better with the parentheses, but both are equivalent. Okay, so whether you remember to factor out the negative or not, you're going to come up with the same answer. I think factoring out the negative and dealing with a product is easier than dealing with this complex fraction, and that's why I always try to remember if I have two negatives to factor out that negative. Okay, let's look at the change of base formula. So, in our calculators, right, we do not have, or unless you have the Inspiron, I don't even know how you say that. All right, we don't have a log base 2 button. Okay, but we can use the change of base. We can change this to any base. So I am going to use the common base 10 because that's the base that I have on my calculator. I can do log base 10 of 5, so common log of 5 over common log of 2. Okay, and so when I plug that into my calculator, I have this nice fraction bar on my calculator. I'm doing log of 5 over log of 2. And I get that I'm about, it's asking, this is also a rounded answer because This is a rounded answer because my calculator is going to round, I think, to 9 decimal places. Okay, this log base 2 of 5 is my exact answer, but it's asking me for this to 3 decimal places. So I'm going to round it to 2.322. Now, if I had picked a different base to work in, okay, if I had picked the other one that I have as the natural log, if I did the natural log of 5 over the natural log of 2, okay, this time I'm going to show you how most of you are going to need to plug this into your calculator. So I'm going to go back to the classic mode for a second. So I always try to be very careful of telling my calculator what's my numerator and what's my denominator. So my numerator, I'm putting it in parentheses. It's the natural log of 5. I'm closing my argument, and then I'm closing my numerator, divided by the natural log. I want to put in parentheses. So the natural log of 2, I'm closing my argument, I'm closing my denominator. You see that I get that same value of about 2.322. Okay, so if you want to graph an equation like this, okay, again, in our graphing calculator, we don't have the base 2, but we can rewrite this as the log of x minus 1 over the log of 2. Okay, so this is how we can put it into our calculator. I'm sorry, I wrote this out so that I'm going to put up my other notes. So one thing that's important to remember, the log of x minus 1 is not equal to the log of x minus 1. Okay, with the parentheses make a big difference. Think about this as a shift of the parent function. This would be a shift 1 to the right. This would be a shift 1 down. Those are not equivalent. Okay, so putting parentheses is super important here. In your calculator, this is what you would type. Okay, you're putting parentheses around your numerator, you're putting parentheses around your argument, you're putting parentheses around your denominator and its argument. Okay, so I put this as some notes. It's super important to put numerators and denominators in parentheses in your calculator. Okay, I hope this is clear. If it's not, come to office hours and we can talk about it. Really quickly, I wanted to talk about why these properties of condensing and expanding were so big. So back in the day, a long time ago, even before I was in high school, right? They had to do a lot of these log calculations manually. Okay, if you think about Katherine Johnson, who worked for NASA, and the movie was just made up about her that I'm blanking on the name. She was a computer at NASA. So I also don't know if you know it, the computer actually meant that she computed numbers. It wasn't a computer like we knew it today. It was an actual person job, and so she did calculations all day long. And they had these log tables that looked like this. So if you were finding the logarithm of log base 10 of 1, we know that that's 0. But if you found the log base 10 of 1.1, it was approximately 0.0043. Okay, and so if we do that with our calculator, the log of 1.1, we get 0.041. Okay, 0.043. So this actually seems a little off from mine. I wonder if it's an ln. No. Okay, so anyways, they use these tables. That's the point. I'm not sure how my calculator is working. But what they would have to do is they would have to find something. So my table only goes from 1 all the way down to 5.5. So they would have to find, if they got an argument that was bigger, like 12, they would have to find a product that was equal to 12 based on values that they had. So for example, you might write 12 over as 3 times 4. And then you could use the product property to say that this is log of 3 plus log of 4. Then looking at your table, the log of 3 is way down here. It would be 0.4771, and the log of 4 would be 0.6021. So then you would plug those in, and then you would do the manual calculations to find that the log of 12 is about, all of these should have approximate signs, I'm being picky, 1.0792. Okay, and so if I find the log of 12, I'll see that it's 1.079 approximately 2. Okay, so be very happy that you have calculators. But again, sort of knowing why we did some of these things, and then these properties are still so important if we are using variables and not numbers that we can't evaluate with our calculator. So I hope some of that was clear. I'm sorry for any mistakes. I'm sorry that it went over into 2 parts. If you have any questions, please let me know.